Hi guys, this is Mrs. Lauterbach, and today I'm going to walk you through how to draw the ionic bonds between a metal and a nonmetal in this worksheet using the Bohr method. We're also going to review some basics in terms of protons, electrons, valence electrons, oxidation number, and type of ion for various elements. So that's actually the first thing we're going to do. And I have a periodic table already with me to help me go through this. And if you notice my periodic table, I've added some annotations to this, and I would encourage you to do that too later on. So one thing I did is I highlighted group 1, 2, and 13 as orange. These are metals. They're going to form what's known as a cation. By losing their electrons, they'll have a positive charge. So I wrote down those oxidation numbers on top. The group 15, 16, and 17, these are non-metals. I colored them green. They are going to form what's known as an anion. They'll have a negative charge because they gain electrons. In blue, group 14, really that could go either direction when it comes to ionic bonds. It depends on what element it's going to bond. So it can either gain or lose an electron. So it's just kind of that middle color. And then lastly, in yellow, I highlighted the noble gases. Remember, in ionic bonding, elements are going to gain or lose electrons to look like a noble gas. So ultimately, we want to look like one of these elements. And then up on the top in pink, those are what I added the oxidation number to kind of help guide me through it. So these are like where the bonds can take place. All right. So my first element is sodium. Okay. So sodium has the atomic number 11, so that means it's going to have 11 protons. All right, and I'm going to put a little plus sign there to help me remember that protons are positive, and 11 electrons. Okay, valence electrons. Sodium is in group 1, so that group 1 means it has one valence electron. That's one way to help you remember. And then the oxidation number is a positive 1. It's going to be easy for that sodium to lose an electron and become more positive than try to find 7 electrons to look like a noble gas. And so this will form what's known as a cation. Alright, chlorine. Let me go ahead and move the table over. Chlorine is in group 17. Right here, group 17, all right, and the atomic number is 17. How about a coincidence? Okay, so it's going to have 17 positive protons, 17 negative electrons. It's in group 17, so that little extra 7 there, that kind of gives you a hint at the valence electron. So it has 7 valence electrons in its outer orbital. And it's going to be easier for chlorine to gain an electron and try to look like argon than to try to lose electrons and go back to look like helium. So in this case, the oxidation number is a negative 1. It's easier to just find an electron, and that'll make it into an anion. Okay, beryllium. All right, beryllium is over here. Beryllium's atomic number is 4. All right, so it's going to have 4 positive protons, 4 negative electrons. Okay, beryllium is in group 2, so that group number helps you determine the number of valence electrons. So it has 2 valence electrons. And it's going to be easier for beryllium to lose 2 electrons and try to look like a helium noble gas than to find 6 and move across. So it's going to lose those 2 electrons. And when it loses an electron, it becomes more positive. And again, that's going to be a cation. Okay. And I'm going to do fluorine, and then I'll have you figure out the rest. So fluorine will be my last one that I'm going to do with you. So fluorine, here it is again. It's in group 17. Fluorine has 9 as the atomic number. So that means it has 9 positive protons, 9 negative electrons. It's in group 17, so that gives you a hint on the valence electrons, so that's 7. And again, it's easier to find 1 electron and move over to look like neon than to lose all 7. So if it's going to gain an electron, it becomes more negative, so that's negative 1, and it'll be an anion. All right, so I'm going to let you figure out how to do the last 3.